So 2.4b, equations containing fractions. Alright, if you're like most people, you absolutely hate fractions. So what we're going to try to do is do what we can to make them go away. When I have a problem with fractions in them like that, I can try to find out what the common denominator is to the 3, the 2, and the 4. In this case it's 12. So what I'm going to do is I'm going to multiply the entire thing by 12. So I'm going to go 12 times 2/3 x plus 12 times 1/2 equals 12 times negative 3/4. When I do this, I get 24 over 3, 12 over 2, and when you do this, I guarantee you'll be able to get rid of your fractions. 24 over 3 is 8, 12 over 2 is 6, 36 over 4 is 9, put a negative on there, fractions are gone. Subtract 6, 8x equals negative 15, divide by 8, x equals negative 15 over 8. So you get a fraction for your answer, but that's okay. It's not a problem to have a fraction for an answer. Plus, it's not that hard to write a fraction as an answer. It's just really hard to solve this without getting rid of the fractions. Okay, so let me give you another one. So in the last problem, we got rid of common denominators got rid of fractions by finding common denominator and multiplying the entire thing by that. Well, in this case, we've got a couple fractions, but what we're going to do is we're going to distribute first. So let's go ahead and do that. Get rid of the parentheses. So we're going to get 1/3 x minus 4 over 3 plus 2x. So we distributed there. Equals 3 times 4 is 12 over 5x plus 3 over 5. Now, common denominators. We have a 3 and we have a 5. The common denominator but for those two fractions is 15. So we're going to multiply the whole thing by 15. So we get 15 over 3x minus 60 over 3 plus 30x equals 15 times 12 is 180 plus 15 times 3 is 45 over 5. So I distributed this 5 to each one of these terms all the way across. So 15 over 3 is 5, 60 over 3 is 20, 30x, 180 over 5 is 36, and 45 over 5 is 9. Combine my like terms, so I've got a 35x minus 20 equals 36x plus 9. And let's get the x's on the same side. So we'll subtract 36x from both sides, make that go away. So negative 1x minus 20 equals 9. Add 20, negative x equals 29. And remember what happens when you have a negative variable. You just make it positive and make everything over here the other opposite. So that becomes positive, that becomes negative. So we get negative 29. Okay, so what happens if we have not fractions, but what happens if we have decimals? Well, we're going to try one with a decimal, and you'll notice that it's done the exact same way as the ones with fractions. So if we have 0.08x and we're adding 0.09 times x plus 2,000, and I say that equals 690. Okay, so again, what we're going to do is we're going to do our distribution first. So we're going to distribute that 0.09. And then 0.09 times 2,000 is 180. And that equals 690. Okay, so what I need to do here is combine like terms first. Those are alike. 0.08 plus 0.09 is 0.17. So I haven't done anything really weird with my decimals yet. They haven't been too bad. Let's go ahead and subtract 180. So 0.17x equals 690 minus 180, which is going to give me 510. Divide by 0.17, divide by 0.17, and I'm going to get x equals 3,000. Okay, so not really too bad. We could have eliminated the decimals, but let's not worry about that at this point. We can try that later. All right, so what we're going to do in this last part of the video is identities and contradictions. All right, so let's go ahead and look at example 8. We have 9a minus 2 times 3a plus 5 equals 3 times a minus 1 minus 7. All right, so let's go ahead and use the distributive property, 9a. So we have a negative 2 times 3 is negative 6a. Negative 2 times 5 is negative 10. 3a minus 3 minus 7. Combine like terms. We got those. Okay, let's subtract 3a. Subtract 3a. And we get negative 10 equals negative 10 because both of those went away. So when you run into a problem like that where the variables disappear and the numbers end up being equal to each other, then the equation is called an identity. And that means it doesn't matter what number you put in for your variable here. You can put in any number in the whole wide world and this will be a true statement. So the solution set is, and I use this meaning real numbers with a double line right there, and the solution set, there's my set sign, is any number. Any number in the whole wide world will work. Alright, so let's look at one more. This is example number 9, and we'll look at the other extreme. So we have 1/6 times 5x plus 3 minus 1/2 x equals 1/3 times x minus 5. Okay, let's go ahead and distribute. 1/6 times 5x is 5/6x plus 3/6 minus 1/2 x equals 1/3 x minus 5 over 3. So let's go ahead and combine like terms. We'll use white here, and we're going to combine this with this. So we actually have 5/6x minus 1/2 x. So we'll just put those together right now. Plus 3/6 equals 1/3 x. There's nothing similar over here. Alright, so I've got a bunch of fractions. I hate fractions. So let's go ahead and find a common denominator because I don't want to combine these two. I don't want to find the common denominator of these two and subtract. If I can find a common denominator of the whole thing, which in this case is 6, and I'm going to multiply everything by that and get rid of these doggone fractions so I don't have to combine that or anything else. So this is 30 over 6, 5 times 6 is 30, minus 6 over 2x plus 18 over 6 equals 6. Remember to do both sides. Alright, so 30 over 6 is 5, minus 3x plus 3 equals 2x minus 10. So in white we get 2x here plus 3 equals 2x minus 10. Alright, so let's see. Let's subtract 2x from both sides. And I get that goes away. Oh, and those go away. So all I'm left with is 3 equals negative 10. That is not a true statement. So that is called a contradiction. Okay? Because this is not true. It's contradictory. We solved for x, and we found out that the number that we solved for is not possible. So the answer to this one is, what is the symbol for it? Looks like this. Let me get rid of some stuff here so I have room to put the symbol. The symbol for this is that. It means the null set. It does not mean that it's equal to 0. It means that there is no answer, because 0 would be an answer. So that is lesson 2.4.